Here's the table in the back of the book with correlations. Note it has a little footnote here. N minus 2 would be your degrees of freedom, so we go down to 4 degrees of freedom. Alpha equals 0.05 column, and you get 0.811 for our critical value. That's the same 0.811 and negative 0.811 that we got here. We reject the null hypothesis, so we say there is a significant linear correlation or relationship. And if you wanted to specifically, we're talking about negative correlation, negative relationship between alumnus contribution and the number of years out of college. Tends to look like the more years an alumni is out of college, the less amount of money that they're going to get back to the college. And there's also the t-test option. We could have done this hypothesis test, works exactly the same as far as the null and alternative. We have rho equals 0, rho not equal to 0. But instead, for our test statistic, we're going to find our t-test. So our t is equal to r square root n minus 2 all over 1 minus r squared. So if you go back again to our lin reg t-test, I'm going to stat test, lin reg t-test in here. Same option as before. There's a bunch of information here for us. So if we, here's our r again, it was negative 0.8829. You want a parenthesis for the whole square root. An arrow up just a tad where it says degrees of freedom 4, that's the same thing as n minus 2. And then the 1 minus r squared needs another set of parentheses. And r squared is down here. We have 0.7795. That's if you were to do that all by hand, but the calculator has that piece for you already. So you can use this to show your work, but you have in here that t is equal to negative 3.75997. So rounding out to 4 decimal places would be 6 with a bunch of zeros there. Then we would have a critical value with a t-distribution curve. So here's our bell-shaped curve, 0 in the middle, two-tailed test. We have 2 critical regions shaded. And you can do your t-distribution table, or you can use inverse t on your calculator. On the calculator, to use it, you go under distribution menu here, so second vars, down to inverse t. This is on the TI-89 under your stat app, and it's under F5 for distribution, so there's a drop-down menu for inverse, then inverse t. If you're on an older TI-84 or the TI-83s and you got the program from me, you can go into program, go into inverse t and start the program. It will look similar to this. It's going to ask you for area in one of the tails. I usually do the left tail just for the symmetry. Just think about this is alpha divided by 2 is 0.025 area in that left tail. And then our degrees of freedom, n minus 2 is 4. So I've typed in 4 and hit paste. Some of your TI-84s will actually start out with this menu, and you just type in 0.025 comma, the comma is right above the 7 key, then your degrees of freedom with your in parenthesis, and then hit enter. Negative 2.776, and it's symmetric, so we have positive 2.776 over here. We're comparing this t, these are t's as well, but those are critical values, and here's the test statistic. That t is out here in the tail, so we would reject H naught. Same thing that we got back with the other method over in here. Same conclusion then. If you're using the t-distribution table to get this number, you go to your table up at the top under two-tailed test, alpha equals 0.05, drop down to 4 degrees of freedom, and you get your 2.776, plus or minus the 2.776 would get your critical values here.